Hello everyone, welcome to thlympic. So we are together again with another 4 questions from International Math Challenge competition. So let's start. So this is our first question from category 1. The question asks the shortest perimeter of these given shapes. They all have the same area, but different perimeters. So the perimeter means distance around the shape. So we will just count these units. So if we consider this as 1 unit, so 3 units, 3. So in this way, if we count all, we will get 12 units from here, 14 units from here, 10 units from this one, and 12 units from the last one. So the option C has the shortest perimeter among these shapes. For question 2, it is about area of a triangle inserted in a quarter circle. So for the quarter circle, we have 2 values given, but to find the area of this triangle, we need height. We have base already. So drawing a radius from O to L will help us. OA is radius, so the radius size is 5 units. So it means this is also 5, and we have a right triangle. So when you apply Pythagoras theorem in this triangle, 3 square plus, let's call this x squared equals 5 squared. So from here we can get x equals 4. Now we have a simple triangle, both height and base are given. So to calculate area, we use the formula 1/2 times height times base. Height is 4, base is 2. So these two are simplified, so answer is 4. For the third question, we have a regular hexagon and a square is inserted inside, and the ratio of area of this square to the area of shaded part is given as x over y in the simple form. So the question asks, what is x plus y? So when we draw these diagonals for the square, so, and we also label these two as kk, so it means one side of a regular hexagon is 2k, and all others are same as 2k, 2k. And also if we join this corner with the center of the regular hexagon, here we will get an equilateral triangle, because if we calculate the interior angle of a regular hexagon, we will get 120, but it is divided into 2 equal parts, because we can make 6 equilateral triangles if we continue dividing. So these are 60, 60, and since these two are equal, it is isosceles. This is also 60, and this is also 60. So we got equilateral triangle, all sides is 2k, 2k, and 2k. Now, if we compare area of this white triangle and this shaded triangle, we see that their height is same, but base of white one is 2k and the shaded one is just k. So it means the area of white one is 2 times the area of shaded one. So if we call the shaded area as A, the white one will be 2A. So we have 1, 2, 3, 4 triangles like this one. It means the square area equals 4 times 2A, 8A. And shaded area is 1, 2, 3, 4A. So when we divide them, square over shaded area is 8A over 4A. When we simplify, we get 2 over 1. So since this is the simplest form, x is 2, y is 1. So x plus y equals 3. So this is our final question related to vectors. So we have 2 vectors given, and the coordinates are given. So we can draw those vectors. This is x12, y5, and x3, y4. And this vector will be between those two, and it is also angle bisector, means these two angles are equal. So first we can calculate size of this vector OB using Pythagoras theorem, because this is 12 and this is 5. So 12 squared plus 5 squared equals x squared. So x equals 13. Same thing we can do it for OA. So 3 squared plus 4 squared equals this square of OA. So OA comes as 5. Now we get the size of OA and OB. And the next step is, since this is angle bisector, so the ratio of AC to CB is proportional with these two values. So if we call this 5x, because this is 5, this will be 5k, because of this is 5. This will be 13k, since this is 13. And the ratios will remain same. So AB becomes 18k. Now, to get OC, the equation of OC, we need OA plus AC. But we don't know what is equation of AB. So to get AB first, AO plus OB. So here we can see it. And from here, AB comes as 9 and 1, the coordinates of AB. Vector AB is x is 9, y is 1. And now AC is 5 over 18 of AB. So if we use the ratio, because if AB is 18k, AC is just 5k. So to find AC, we multiply AB by 3 over 18. So, and when we multiply this 5 over 18 by each coordinate, and when we simplify, we get 5 over 2 and 5 over 18. So this is the coordinate of AC, this one. Now the final step is to get OC, it equals OA plus AC. OA plus AC. OA we know, AC we know. So we got this one. Now this vector is parallel to this vector because both of them are on the angle bisector. So if two vectors are parallel, one vector equals a number times the other one. So let's call this number as m. So m times one vector equals the other one. You can write this m here or here, doesn't matter. So now to solve this kind of equation, m times 1, m times a equals these two. So m times 1 equals this one. From here we got m, and m times a equals the second one. And since we already know m, we can substitute. So a equals 77 over 18 divided by m, and m is a fraction, so we flipped it and multiply, and after we simplify, we got 7 over 9. So this is the answer of this question. So thank you very much for listening me. Hope you enjoy it, and see you in next